Hi, welcome to the From Zero YouTube channel. In this video, I'm going to teach you in about 90 minutes the basics for the Python language, specifically Python 3. And even though you're not going to get like the complete knowledge of the language, it's a pretty good introduction. If you want to like learn more and start doing like web applications, I recommend you do one of my courses. But having said that, we're going to use an IDE or a code editor called Cloud9. And what it allows you to do is to not have to install Python in your computer. And if you're at work, you can like basically use and do this tutorial using this incredible technology, which is basically like a server that you can do coding in through your browser, through the internet. So I'm going to do a little bit of introduction of what Cloud9 is, and then we're going to go into Python. And in about 90 minutes, you should start kind of like having a good idea of what Python is. So see you in a bit. Okay, so let's get a little bit acquainted with the different areas of Cloud9. So first, you head over to c9.io, and you can basically just click on Try It Now to register your new account. Once you click there, you can sign up with, if you have a GitHub account or a Bitbucket account, you can sign up with that. Otherwise, you can choose a username, an email, and a password, and select here so that you can get like a CAPTCHA, and then create your free account. Like I said, they have a free account tier. They also have like some paid account tiers, but for the purposes of this course, you don't need to really get into a paying account. So I'm gonna log in with GitHub, and when you sign in or you register, you get basically this area which is the dashboard, and you have what they call workspaces. And workspaces, think of them as basically different projects, and they're actually basically like separate servers that you're creating with applications in it. So initially you get this test workspace, and then you can create a new one, which is what we're gonna do when we start our first Flask application. But let's see what happens when you select an existing workspace. But before we get there, if you click here on the name of the workspace, you basically have the capacity of like doing some editing. You can have you'll see a README. You'll have the files that are in there, so you can take like a quick look. Only README is here in this test project. And here's a very interesting one. You have members, and in members you can basically invite. If you have invited people, you can see them in there. To invite people, you need to be inside of the actual project. But you'll also see how much CPU you're using, how much of the RAM and how much of the storage you're using. And they have, for the free tier, you can have up to 1 CPU, 512 megs of RAM, and 1 gig of hard drive, which is more than generous, I find. But now that we know more or less what's that about, like I said, you click on the name itself, you'll see those statistics. But in order for us to actually start doing stuff, you click on this green open button. So once we click open here, we're gonna be taken to what's called the IDE, or the Integrated Development Environment. And basically this is kind of like a code editor. Also has like a terminal here for the server, and you have basically a file navigator, as you can recognize from similar type of applications, like code editors, or even Word editors. But here you can basically navigate what's in the folder. Right now we only have this file readme md. On this side here we have basically you can edit anything. and you have an undo function as well if you want. And it shares like a lot of the things that normal code editors have. So it's very very well built. Has a lot of capacity. You're not giving away a lot of power because we're using this integrated development environment. And here at the bottom we have the terminal, and this is something that I always kind of force students to kind of get very acquainted with, because it's basically the way that you interact more with systems. We don't want to get used to using like graphical things. We want to be very comfortable with the terminal. If you click on this little kind of like window function here, we will get a standalone editor, and you can minimize again by clicking on that little icon. And one important one that you want to remember is Control-Scape, which basically shows and hides that terminal back and forth. You can also like add tabs here. For example, you can add a new and I think when you open it for the first time, you'll see this immediate JavaScript editor. I usually close it because it's not something that we're going to be using for this course. So you can go ahead and close it. But you can have another terminal window, let's say with another folder open, or things that you want to do as well. But in any case, it's a very nicely integrated environment. And what we're going to look at next is some basic terminal functions, so that you guys get better acquainted with terminal commands and how to copy and navigate directories and things like that. So let's start playing a little bit with Python, and we're gonna use the terminal again, and we'll maximize this here. With Cloud9, we have an option to use both Python 2 and Python 3. Python 2 is still very much in use because there's some libraries that still haven't been ported to Python 3, but I would say these days most of the useful or most common libraries and frameworks have been updated. So I'm definitely and I would start using Python 3 from this point on. And you know, it's a good thing that we start using Python 3 in our projects to kind of like move our community, our Python community, towards that newer version. So the way we access, if we use only Python like this, we're gonna be basically using Python 2.7, which is the last 2 version. You can do -v to check the version of it. So as you can see, Python 2.6, 2.7.6, I mean, is what you get from Python. But we can also use Python 3 by just typing Python 3, and then you'll see that we have 3.4, which is the latest Python version. So that's good. So there's a way to play with Python, and that's through the Python shell. And the way you do that is you just type Python or Python 3, and then press enter, and you'll enter this basically terminal where you can play with and do like small kind of functions and get to know Python better. So let's start doing some commands and start playing with it. Okay, the first thing we're going to do is use Python as a calculator, just so you get an idea of what things we can do. If I type 2 plus 3, I get 5. So, you know, that's basic stuff in there, but just so you get a feel for it. So 3 minus 1 is 2. For multiplication, you use the star. 3 times 8. For division, you use the slash. 10 divided by 2. One thing you'll notice is that in this operation we got a what's called a floating number. So it wasn't 5 integer, but it was 5.0. That's because Python is basically kind of like advancing or forecasting that you might get not integer numbers. So if we do 10 divided by 3, you'll get 3.3333, which is the floating number. We can also do exponentials by doing 2 asterisks. So 2 to the power of 3 is 8. And you can also get the modulus, which is the remainder of a division. So 10 modulus 3 is 1, because 10 divided by 3 is 3, and then you get one more as the modulus. The last thing here is like we can group terms together, because usually divisions and multiplications come before subtraction and addition. So for example, if we do 2 plus 3 times 5, what we'll see here is that the multiplication comes first, so it's 15, and then it'll add to 2, which is 17. But if we wanted to do the 2 plus 3 first, you put a parenthesis there, and then in that case we'll get 2 plus 3 is 5 times 5 is 25. So that's kind of like basic arithmetic functions. One key concept in Python and in other languages is the concept of variables. And variables are basically boxes where you can store some value in it, and then you can reference that value from that box's name, so to speak. So let's say if I have say a variable called x, you assign it a variable using the equal command, and then you do 3. So from now on, x is equal to 3. To see the value of a variable, you can use the print command. So you do print. We use parentheses in Python 3. It used to be print without parentheses x on Python 2. So now we get the value of it. Because it's a variable, we can change the value whenever we want. So now if I do x equals 4 and do the print of it, I'll get the new value. So as you can see, you can change the values of a variable really easily. You can also assign, say we have another variable called y, and we can also then now assign x equals y, and that will assign the value of x to the current value of y, and we'll see why I say that. So if I do print x now, you see that I get 7, but if I change y to 10, what do you think the value of x is? The value of x is still the old value, because this was passed as a value and not as a reference to the value. So for me to change the value of x, I need to like reassign x equals y, and then if I do x, now I get the updated value. And of course I can sum those variables, x plus y equals 20, and do multiplications and all that. Another interesting thing is that I can also assign strings to variables. So if I do, let's say now z equals hello, if I print c here, you'll see that I have hello there. And if I have another one, let's say zz equals world, if I type z plus zz, what happens there is a concatenation. It's not going to add the values of it, but it's going to just concatenate the strings. However, notice that we have no spaces in between, which is, what we're basically telling it to do. So in order for us to put a space, we would have to do something like z plus quotes plus cz, and then we get the proper hello world. One thing that you cannot do is add a string to a number. We get an error there because we need to basically convert the z to a number, which is not possible. But for example, if z was 1, right, and zc was equals to 2, if I do c plus zz, I get that error, right? But if I do int of z, that's basically convert z into an integer, and then I do plus zz, then I do get the proper result. So that's more or less an introduction to variables. We're gonna use them a lot, so we're gonna get pretty acquainted with them as we move on to the course. One thing that you want to get used to or know about is something called PEP8. So if you go to Google and just search for PEP8 and put Python, just in case, you'll see this PEP8 guideline. And this is basically the style guide for the whole Python coding. And that includes how to use code, using tabs or spaces, what's the maximum line length, and it basically goes through all the conventions for those functions or things that we normally do on a daily basis. So when you have a chance and you have you're having a long lunch and you want to get used to or get acquainted with all the recommendations for how we type code in Python, then you should definitely read this. But in any case, going back to variables, for variables we use basically numbers, letters, and underscores. So basically, a good variable name is my var. So notice I use an underscore whenever I have spaces in there. So I don't do this, my var, or do my capital case var, which is something that JavaScript uses. So, and the other thing is try to make variable names as explicit as possible. Make them meaningful. Don't do XX like I was doing ZC before. That's not a good practice if you're writing a real project. It's better to put database index value versus just DBI. Try to use explicit names, things that people reading the code can understand what's going on. There's also it's not in none of this is really enforced, but it's again what PEP8 dictates. When you have a constant, which means it's a number that's never going to change, we use all caps. So for example, database name, for example, equals test. So that's kind of it's a good practice to have caps, because that means whenever the person or the developer reading the code looks at that, he knows, oh, this is something that doesn't change throughout the code base. It's a cap. It's capitalized. So that means it's not going to change. But there's other things that you should definitely look at, and take a look at PEP8 when you have a chance, because it's useful for you to get acquainted with it. A way to check the type of the variable or the number, not the number, but um, the term that you have is through the type command. So for example, if I do type of 1, it says it's a type of integer. So basically it's an integer number. If I do type 1.0, then type tells me that's a floating number. That means it has decimals in it. If I do x equals 5 and then I do type of x, it says it's an integer because it's assigning it to an integer number. So that means the variable is inherits the type of the value. And if I change that to a string, and then I do type x again, I get the new class is a string. One thing that you have noticed maybe is that I can press the arrow top and bottom to kind of like go through history, so I don't have to like retype things again. And once again, if I do type hello, which is a string, I'm gonna get type of string. So that's a useful thing to know and learn when you want to like know what the type of a variable that you don't know exactly what it is kind of like is. And this goes a little bit as you see there. It says class. We're gonna get into classes in later in this section. Let's take a look at some string functions and helpers. Strings can be expressed as quotes, like x equals hello, or as single quotes, x hello. One thing to know is that strings are basically arrays. And we're going to see arrays, which in Python they're called lists, in a little bit more detail afterwards. But basically think of an array as a collection of individual characters. So what that means is that if I do, let's say, x of 0, that means that I'm going to get the first character of the string. If I do x of 1, I get the second. So as you can see, it's basically a collection or array of the strings HELLO. And that's something to remember when you can kind of like get the substrings of a string by putting a range of characters. For example, if I do 0:3, I will get the first 3 characters of that string. The same way, if I do 3 through 5, I get the last 2 characters. The other thing is, as we were seeing earlier, we can concatenate to strings. So if I do y equals Paul, then we can do x plus y, and I get hello Paul. If we want to do like the space between the two, I just insert that space in there. We can convert a string a number to a string by using the str function. So for example, if I have, let's say c equals 3, and remember how we said that we cannot concatenate the integer and a number. If we wanted to say hello 3, we would do x plus str of 3 of z. So str will convert the number 3, which is an integer, to a string, and there it works. If you want to do the opposite, remember, like if we wanted to have a string that was basically a number and we wanted to get the value of it, then we do int. There's also some methods that we can use that are already built in on the strings. For example, if I wanted to have the hello all in uppercase, I would do x.upper and that doesn't make a lot of sense. I guess let's say y.upper, and we'll see Paul all in caps. And if we want to get them all to lower, then we do x of lower. So there are more methods like that, but you get an idea of some things you want to, there are certain methods that you can use. And one last one that you'll use often is len, which is what's the length of a specific string. So len of y is 4, which is Paul. So take a look at string operations when you have a time. There's lots of them, but these are kind of like the ones that are used most often. So let's take a look at 3 very useful types of variables. One is called lists, and list is basically a list of values that can be numbers or strings or both. So let's say x is 1, 2, 3, and you close them with brackets, and that means that that's a list. So if we print x, you get the whole list. If you get type x, you get the type class is list. So lists are very useful if you have basically an ordered or an ordered kind of like list of values that are that you need to get access to. And a lot of times things that come from like the database are returned as lists, so you want like be able to loop through them and get their values. So one thing you're able to do is loop through a list, but that's something that we're gonna look at a little bit later. Another type or another kind of like different storage function or class is tuples, and tuples is basically used with parentheses. So you can do x equals 1, 2, and that's a tuple. So if you do type of x, you get a tuple. So one thing that separates the list and the tuples is that you cannot, once a tuple is defined, you cannot update the values. So think of a tuple as a constant of a constant list, or a static list that you cannot change afterwards. To get both a tuple and a list value at a specific position, you do basically x of, let's say, the index. So x of 0, which is this tuple, is 1. X of 1 is 2. So it's always always starts the index at 0, something that sometimes we forget. But basically you can get any of the values of that list or tuple using that notation. So let's say that I want to show you how we can change the value of a list but not of a tuple. So let's define that x again as 1, 2, 3. If I do x of 1 equals 4, now if I print x, see that I just replaced the second value to 4. But if I did this tuple 1, 2, 3, and you'll notice that I put a comma afterwards. That's kind of like the way that you work with tuples. You have to kind of like end it with a comma, even though you're not putting a value there. So if I do y of 1 equals 4, I'll get an error because there's no item assignment on tuples. The last type that we're going to see is called dictionaries. And dictionaries are basically key value objects. So basically, if I do, let's say, uh, first is Jorge, and then last is Escobar, and then I use curly brackets for those. So this is a dictionary, and the way you reference it, instead of doing x of 0, which you would do in a list, you do x of first, and that will return Jorge. A lot of times these are called objects. Dictionaries are called objects because it's kind of like the first and the last are properties of that object, and the values are the ones that you put afterwards. And the last thing that we want to see is you can do a list of dictionaries, which is something that you'll see a lot when you're interacting again with databases. So, for example, let's say we have users equals, and then we have let's say let's define another user as y equals first Paul, and then last name is Graham. So now I can do users equals x comma y. So that's a list of users. If I print users, I see that I have all these objects there. And something you'll notice is that I set to the dictionary first equals Paul and last is Graham, but now it's printing last first and first second. That's something that you cannot control on dictionaries, is the ordering of the keys, and it's stored basically randomly in Python. Basically, there's no guarantee of that of ordering of those keys. But there are things that you can do to kind of like manage that, but something for you to like always remember. Python has great control functions for dates and time. Again, there's a lot of information, but we'll see some like really simple things that you can do. So the first thing you want to do is import datetime, which is a collection of date and time functions and utilities. By the way, we haven't seen this before. So import basically means loading to memory this specific module, and this is a lot of how Python works. It's basically you import or you kind of add any of the libraries or utilities that you have in your file system, but you don't need to like have them all loaded at once. So that's how you pick and choose what utilities you're going to be using in a specific file, and we'll see a lot of that as we get into the course. But now, after I press enter, I have all these datetime functions available to me. But one we're gonna see is like it's this called datetime now. And what that means is that it's if I print that, I get this date, which is today's date and the hour right now of the computer. So basically, since Cloud9 operates in the cloud, I believe this is set already to UTC, which is basically the universal time, or Greenwich time, as you may have heard. And this is a very good practice. You never ever use the local time to store as your timestamps, because you're gonna be basically users are gonna be in different time zones, and you don't want to be doing conversions after the data has been stored. So remember, this is a golden rule: always store time or dates in the database as UTC. But we'll see how we do that. For now, let's say this is the local time. So if I do now, let's say type of now, you'll see that it's of type daytime. But now I can do things like y.year. Now the year, and you'll see that I get the year for that date, and I can say now.hour, and it'll tell me the hour. So I can basically be able to parse different parts of that data. In order for us to store the UTC properly, we need to import this specific class or function called datetime, from datetime import datetime. And now what we can do is let's say time UTC, and we assign that to datetime UTC now, and that will give us the UTC for this exact moment. And as you can see, it's basically the same hour as Cloud9 gave us as the local time, which is smart. I mean, they're using UTC as their time, so you don't have to do you don't have to deal with that conversion manually. But I still kind of expect and store things using this function UTC now versus this now function. Something for you to always remember. So let's take a look at two very important parts of Python called conditionals and control flow. So conditionals is basically you want to compare one value with another. And so basically, if we have x equals 3 and y equals 4, a conditional would be is x lower than 4. And all those conditionals give us a either true or false. They're basically booleans. Booleans are like logical true false kind of variables. So if I do x is greater than 4, then I get a false because 3 is not greater than 4. I can also do is x greater than y, and that gives us a false as well. One thing that we can also do is x is not equal to y, and that will give us basically is then the value of x is not equal to the value of y. We can also do x is minor or equal to let's say 3. That's true because even though it's not less than 3, it is equal to 3. And the same thing, y is greater than or equal to 4, it'll give us true as well. So those are the basic ones. Then control flows is basically you can control the where the program goes by doing if conditions, right? So if I do if x is lower than 4, then you put a semicolon there and you press enter. You see how we have 3 dots there? That means that Python is expecting you to put a kind of like the inner piece of that conditional. So you can press 1 space. Normally you have to do 4, and in the editor you'll see 4, but in the terminal you can do just 1, and that's fine. So if x is minor to 4, then print x is lower than 4. Okay, So then if I press enter and then print enter again, then it'll execute that because x, which is 3, is lower than 4, so that does execute. But let's say if we wanted to do if y is greater than 5, which is false, right? So we can do print y is greater than 4. What will happen here is that nothing will get printed. Why? Because y is not greater than 5, so it'll skip and continue on, but there was nothing else to do there. So one thing that we could do is do an else statement. So if you do if y is greater than 5, then I print this, and then I put else and also semicolon there, and then put print y is, say, not greater than 4. So if I press enter again here, you'll see that it'll execute the second line. See? So that's if else. There's like, you basically build all your programs using a lot of these like building blocks. So it's very important for you to know them, and we'll get to know more of them as we continue with the course. Okay, we'll take a look at functions now. So we can define our own functions by using the keyword def, which is like define. So define, let's say, +1, and then basically you can have nothing here, or you can have parameters, which are basically variables that are set whenever this function is called. So in this case, we're going to pass an x variable. So once that is set, we can do stuff with that variable. So for example, we can say x equals x plus 1, which that's why the function is called +1. And then we can then print x. Okay, now we have that function, and if you type plus and then press tab, you'll see that Python auto completes that because it already has that in memory. So for us to be able to see what happens there, we can pass 5, and when we enter that, it'll return 6. So what happened there? It called the function, it passed 5 as the x, basically x equals 5, and then it did x equals x plus 1, and it printed that value. So if we did here 15, we get 16. So you get the idea. That's kind of like what functions are, and we basically use functions all the time as well. It's very important that we understand how they work, but play around a little bit with functions and see what you can get out of them. One important thing that I want to let you guys know and remember, because it's a fundamental thing, there's something called scoping, and basically the variables that are defined within functions are not exposed outside. So in this case, if I print x here, you'll see that I don't get anything because it's not defined, even though it's there within the +1. But that variable is called it's called a local variable to that function, and that's the way that Python kind of like protects the data from the outside to within the function by using that separation. So remember that. Sometimes students forget this and they're like, why can't I get x if it's within the function? Remember that that variable is only seen and it's only apparent or usable by that function, but not outside. So something that you may have heard is that Python is an object-oriented language, and object-oriented programming is something that has been being used for a long time, and there are languages that are object oriented like Java, Python, but some others are not properly object oriented like JavaScript um, and PHP, which they kind of like have been getting towards object orientation. And the main benefit of object oriented programming and using that concept is how to better manage data and make things reusable, and basically allow you to separate logic in a better way. It's a concept that you'll not grasp immediately. It's something that you'll kind of struggle a little bit, and you'll get to it by practicing a lot. But think of objects as let's say a basically a physical object that's represented digitally with basically two things. One is properties and the other is methods. Properties are, for example, if you have a car, a property could be the number of wheels, right? Which is, for a normal, like let's say sedan, it's 4, but if it's a truck, it's like 16 or whatever the case might be. That's a property. And a method would be, start the engine. Something that it's kind of like a function for that object. And the class, we call classes basically as the blueprint or the schematics for you to produce an instance or a clone of that object. So let's do an example. Again, if you don't understand it completely, there's a lot of things that you can read, or even by using Python and Flask, you'll get a better understanding of what classes and objects are. But let's do an example. So one thing you'll want to remember is that classes are defined with basically a uppercase for each one of the words and no underscores within them. That's kind of like the PEP 8 of them. So let's say we're gonna define a class called car, right? So the car, I'm gonna just have a basically a property called brand. So I'm gonna define a method called set brand, and you always put self as the first parameter for these functions that are within the class. And it's basically a way of saying this can only be called from an instance of that car. And we'll put something here called brand. So then I'm gonna say the brand of the car is whatever you passed as that brand on that function. And let's leave it at that. So basically now I can define copies of that class or objects or instances, basically instances of car that are basically clones of each other, and I can set a brand for each one of them. So for example, if I say X is an instance of a car and I put parentheses here, if I put type of X, you'll see that it says it's a type of car, right? But now, if I print X, I won't get anything. It's just a car object. But now if I want to set the brand, I'll call that function by doing x dot set brand, and then I'll put Toyota. Okay, so now if I get the brand of the car, I do x dot brand, and I'll get Toyota. So then I can do another car, which is Y, and then I'll do y set brand Ford, and then if I try to get X the Y brand, I'll get Ford. So basically, X and Y are instances of the car class. They're basically cars, and I can set more functions to them, which are called methods. In this case, set brand is a method, and manipulate or define properties like brand is a property. So we'll see a bit more of that as we go along, but that's basically a very brief introduction of what classes and objects are. A couple of things I wanted to add to our class lecture is one of them is called magic methods, or they're kind of built-in methods. And we're going to see one that's really important. It's called the init function, which basically instructs how we initialize an instance of the class by requiring some variables to be passed. And the other one is the notion of subclassing, which is basically you can take a class and then extend it, and that's called inheritance. You can inherit all the methods and all the characteristics of that class by passing the class as the first parameter. But let's check out how that works. Okay, so we're going to enter the Python interpreter again, Python 3, and we're going to define again the class car, and without any parameters in there. So I'm going to define a new method, a magic method, which is present in many classes. It's very often that we use this, and it's called init. So init, what init says is that whenever you create a new instance of the car, you need to pass these variables that I'm going to be listing here. So I'm going to do that by saying I need to be provided the brand when I create the new car instance. So I'm going to indent here again, and what that init method does is it's going to set the self brand to whatever you passed in brand here. Now I'm going to create another method. This one is not a magic method, which is called get brand. And what that does is it's going to just print the brand. Okay, so now if we execute this, so let's say we're going to have our first car, and it's going to be, let's say it's my car. Let's call it my car. And it's going to be a type of car, right? Well, remember, now we need to, instead of putting two parentheses like we did before, we need to pass this magic method init. And init, by the way, I don't know if I said, it's 2 underscores init and then 2 underscores. All magic methods have that protocol. You need to pass 2 underscores. So here we're gonna pass Toyota as the brand. So what happened? Basically, I created a new instance of a car class called my car, and when I initialized it, I needed to pass this brand. So this Toyota string is going to be assigned to that variable that we're defining on the init, and then it's passed here to the self brand, which is the local or the local variable brand that car has. So now if I do my car dot get brand, it prints Toyota. So that was set properly, right? And this is the same thing as just accessing the brand directly here, which is Toyota. But as you notice in the top one, the top example, it's not returned with quotes because it's just printing out on the screen, versus this is actually the variable Toyota. So that's a magic method. There's many more. One that we're going to be using on our examples on the database. It's one called REPR, or reproduce, I guess it stands for, and that basically will print the representation of that record, of that database record on the terminal whenever you pull it. And there's others that we're going to be looking at as well. Okay, so now let's look at inheritance. So inheritance is basically, I want to create a new class, but I don't want to, like, let's say, do this all the definitions and all the things that class already has. So I want to build on top of it. This is very common when you, like, let's say you're working on an open source project and some other person wrote all these great functionalities around, let's say, communicating with a with an Arduino on your that you can connect to your laptop, and you want to build from on top of those libraries. Then you can inherit those libraries or those classes that library defines without having to repeat all the work that other developer did. So this is a very powerful thing that object-oriented programming allows us to do in Python. So let's say that I want to create a new vehicle type of class called truck. But this time around, instead of leaving it empty, I'm going to pass car as the parent class. And there's like a kind of like a parent child kind of like relationship in there. So this class truck, when I do that class truck car, it's inheriting the init method and the get brand method. So I can basically, it's basically the same thing, but then I'm gonna like define a new kind of like method on top, which could be, let's say, tow car, or rather this tow car. So I'm gonna have a tow car method, and I'm gonna say when I call that, it's gonna print out towing car, right? So that's it. It's a very very simple class called truck. So now I'm gonna define an instance of that. It's my truck, and I'm gonna pass truck as the class. But notice that I need to pass the brand, because it's basically that is required when I defined the truck class as a subclass of the car class. So let's say this is a Ford truck, right? So see that it didn't give any error or anything. It's fine. If I get my truck dot get brand, you'll see that even though I didn't define that method in here, I still have it available, and it says Ford. See, but my truck has a very specific thing that it can only do. Not the car cannot do that, which is tow car. So if I do tow car here, it says towing car. What do you think happens if I try to tow a car with my Toyota, which is my car? Any guesses? Well, we basically get an error because it says that car object has no attribute tow car, and it's saying attribute. It's basically like a method, but that method is not available. So that's what happens to that original class. It's not modified at all by this new method that truck is defining. Okay, so now we're gonna see how to do this kind of operations without using the Python terminal, and basically we're gonna start creating some files. So to do that, I'm gonna create a new directory. So we're here in workspaces. So we're gonna make a directory called module tests, and as you can see there, it created module tests. There's no files in there as of now. So what we're gonna do is we're gonna create within that. So I just control click or alt click, and we're gonna create a new file here, and it's gonna be called car.py. Usually you name the files as the class they contain, but it's not a hard rule, it's not required, but we're gonna do that here. So now remember how what we were talking before, we were doing class car, and then we're gonna say init self brand, and then we're gonna do self brand equals brand, whichever you pass in there, and then we're gonna do another method called get brand, and in there we're gonna print self brand. So now we save it. By the way, this little gray little ball there, that means that we have unsaved changes in the file. So make sure that you always see that little X instead of the little gray ball. And I don't know if you noticed when I pressed the save, it went from like yellow to green really quickly. Yellow means that it's like the request is going out, and then green means that the Cloud9 server actually was able to save that file. So let's try now to interact with that class. And so before you do anything, we're not on that directory module test, so make sure that you go inside, and you'll see why a little bit later. So now that we're within module test, I'm going to call the interpreter the terminal, and we're gonna now be able to work with that class. So the format for that is you usually put from file name without the py from car import car. So I'm telling Python from the car py file import the car class so that I can do stuff with it. So as you can see here, a new directory popped up here called pycache underscore pycache underscore. And within it, you'll see that it has some like strange file that ends in pyc. And it's basically, this is the compiled version of this file of car.py, of all this. And it basically allows Python to execute these files faster. So that's why Python is a very good language in terms of speed, because it'll use these compiled versions of your file instead of having to run the file from scratch every time. So now whenever I execute anything from car.py, it's going to look first if it has a recent compiled version of it, and then it'll load that instead. And if you open that file, you'll see that it's all gibberish, so it's all like machine code. So something to look for. Also make sure that if you're using Git, to ignore underscore pycache underscore directories, because there's no use for you to put this within your repository. So now I should have the car class available to me in memory. So I'm going to do the same thing as I did before. I'm going to do an instance of the car class with the brand Toyota. And now if I do my car get brand, and you'll notice here that I completed with auto-completed with tab. So see this? If I press the tab here, it already knows what methods it has available. So that's pretty usable. So if you do this, I'm gonna get Toyota. So remember how I told you to go inside that directory before? So let's exit. You can do Control D or type exit like this. And let's go back to the previous folder directory, workspace. And let's do Python 3, right? And I'm gonna do the same thing from car, import car. I get an error. It says no module named car. So this car file is not being able to be loaded on the directory, from that directory, I mean. So what's happening here? So basically, if where you run Python from makes it's very important, and you're gonna see no module name blah a lot in your careers. It's just, try to do some common sense and ask yourself, where am I running Python from? Are the directories that I need for those available to me? So the way that you fix this error is basically you need to check that you have another magic thing here, but this time it's a file, and it's called init.py, just like the init on the class. Now we're gonna need to create an init file within module test. But before I do that, let me delete this. And one thing that you'll want to always do in your work is to be organized, or well organized. So I'm gonna delete the PyCache file, and I'm gonna cd to module test, and I'm gonna create a directory called vehicles. Because what I wanna do is I wanna put all the classes that have to do with vehicles within this folder. So now I'm gonna move car py within vehicles. Okay, so now vehicles has that. And for us to be able to call vehicles a module, okay, I'm gonna create a file called init.py. So new file underscore init dot init _py. So it's _init dot py. With this file, you don't have to put anything in it, although you can technically I'm gonna say yes to this. No, don't keep it. That's the old car py. Okay, let me open it here. Here you can put also code, and whenever you import from that module, that code is gonna run. But for this time, we're not gonna do that. Okay, so now notice that I have the vehicles folder in there. If I see what's inside vehicles, I have the init.py and the car py, and I'm gonna run Python from the top folder, module tests. Okay, now you're gonna notice how the format is gonna change a little bit. I'm gonna say from vehicles dot car import car. So what's Python saying there is that from the vehicles module, and what defines that as a module? Because it has an init.py file within that folder. So it treats vehicles as almost as if it was a py file itself. You see what how interesting that is. And then you're importing the car file inside that vehicles module, and then you're gonna import the car class. So now I can do the same thing. My car equals car Toyota, and then my car get brand. See, everything works perfectly fine. So I'm running Python from here, from module tests, but I'm importing from vehicles car py the car class. Okay, so that's something that it's really important for you to manage and to be able to master. And something that even as an experienced developer, this module not found thing is you're gonna have it, and you just have to like stop for a moment and think of yourself, where are you running Python from? Those are called the paths. So you can also like define paths that can be searched, so to speak. We're gonna see that throughout the course. But remember to have that init.py file on your module so you can do stuff with it. Okay, one last thing that we're gonna see here in this lecture is, let's say that I want to do Python 3 and then import, do all that. I want to like run a script that does all that for me. How should I do that? So we're gonna create a new file at the level of module tests, and it's gonna be called, we're gonna call it run.py, okay? And what's run.py gonna do? You're gonna be able to basically do what we said or we did on the Python interpreter, but programmatically. So we're gonna do the same thing that we did before, from vehicles, car, import car. And so now we're gonna do, let's say my car equals car Toyota. And then we're gonna do my car get brand. This is something really interesting. You see how Cloud9's editor is kind of loading the models or the methods. It even's gonna, it tells me like what parameters do I need to pass and all that. So this is pretty useful. It's kind of like already giving me hints of what methods are available. So that's that. We're gonna save that. And now, instead of loading the Python terminal, we just do Python 3 run py. And there you go. You get Toyota. That's what it just ran all those commands and it printed out Toyota. Okay, the last thing I want to cover here with our Python introduction is function arguments, or in this case, class method arguments. And you'll see this a lot in working on a daily basis. So there are two types of functional arguments, or function arguments rather, and they're either keywords types or positional types. And what that means is that when you have a method like getBrand, in this case we don't have any arguments. We don't require any arguments to be passed. However, there might be an instance where you want to have another function, and let's create one that's called openDoor for our car class. And in this case, I'm gonna say door number is a parameter or an argument for that method. So what that means is that you need to pass, in this case, an openDoor function to that class, or rather that car instance, and define what door number you want to open. So let's say it's 1 for the driver and 2 for the to the side of the driver's side, and then 3 and 4 for the 2 in the back of the car. And I'm assuming that it's a 4-door car. So in this case, I'm gonna just say, let's do a print statement, and we'll say opening door, and then we'll just tack on the door number. And let's make this as str, because it's a number, and that's the way that we should be able to concatenate those two strings, right? So we save that. So here what I'm defining is that the door number is actually a positional argument because it's the first one, okay? And we'll see a better example when I do another one. But let's play with this. I'm just gonna run the terminal, and let's say from vehicles .car import car. Oh, I think I'm not in the right directory. So let's go to module tests and try that again. So there we go. So now we have, let's say my car equals an instance of car. And I believe now we need to pass as part of the init the brand, right? So it's Toyota. So if I do my car get brand, we'll get that. But notice, so I'm gonna try to open a door, right? So let's say I want to open the driver's door. So I say open door, and if I don't pass anything, I'll get an error because it's saying it's requiring one positional argument door number. What that means is that it knows that the function requires that the first does the positional moniker here. The first argument needs to be some sort of value that the function needs. So I'm gonna try that again. I'm gonna say my car open door 1. So now I get opening door 1. If I pass 2, I get opening door 2. So as you can see, that variable is being assigned here when I call that function, and then it's printing it out here, and it's kind of like available for that function from that point on. Okay, so now let's try another method we're gonna add, which is gonna be we're gonna have a function or a method for this class that allows me to turn on or off the blinking lights. Okay, so let's say def blinker control, and what we're gonna pass here is gonna be left blinker and right blinker. So I'm gonna have to say it's either on or off. Okay, and here I want to keep like the status of the blinkers in the kind of like in the class itself. So I'm gonna say self left blinker equals left blinker, self right blinker equals right blinker, and I'm gonna just say print I want to say left and then the status of that blinker, and then right str self right blinker. Okay, and close that. So what I'm gonna do is I'm gonna actually check with an if so that I can turn on and off. So if left blinker, actually no, that won't work, and I'll tell you why in a second. So we need to pass both of those functions. Okay, so once again I'll do the Python here, and I'm gonna import and put an instance of the car. So now I'm gonna do my car dot blinker control, but I need to pass left blinker equals say on, and right blinker equals off. So now it's saying that the left blinker is on and the right blinker is off. But you know, when you're driving the car, you don't really toggle or pass both of those things. You either pass one or you pass the other, i.e. the little kind of lever, right? When you put the lever to the upright position, you're turning right, and then if we put it on down position, then it's you're going left. So I want to make the function kind of like behave a little bit like that, but the problem is that I need to pass both. So what happens if I just pass the right blink or the left blinker only? I get another error. It says missing one required positional argument, right blinker. So you see here it's like saying I need to pass the second one, and so that's kind of like annoying, right? So what do we do there? So we have the option to do something here, which is we convert this instead of being a positional argument, we're gonna do this as a keyword argument. The way you do that is you can put an equal sign in here, okay, and then you can load the value of those arguments, and from that point on, it's going to be an optional, or basically you can either pass it on or off. But let's just start with this one, with the right blinker, so you see this how this works. So I'm gonna say the default value of right blinker is gonna be off. Okay. So if you don't pass that, it's fine. It's gonna be Python's gonna say, oh, right blinker wasn't passed, so that's fine. I'm just gonna pre-default it to be off. So let's see that in action. So we'll do this, importing this, and then I'm gonna say my car is car Toyota, and now I'm gonna just pass the first one, which gave us an error before. So let's see what happens. See, now I can pass only the first one. I mean the left blinker one. And the other one I didn't need to pass. So that is, from that point, it's called a keyword argument, because the keyword is right blinker, and it already knows that might be or might not be passed to the function. One golden rule that you need to know is that you always pass the positional or required parameters to the left, and then the ones that are optional or keyword arguments to the right, or basically trailing. So always list the ones that are required first, and then the ones that are optional or have a pre set value to the trailing side. So now I can really do what I wanted to do at the beginning, which was basically have this kind of on a toggle basis. So if I put both by default are off, I can say if left blinker equals on, then set the self left blinker to on, and then put the right blinker to off. And the same thing, if right blinker, and that's like else if right blinker is on, then you want to basically put the right blinker to that value and turn off the left blinker if it was on already. And take this out. So now the function is going to be, if I pass the first one as on, then the right blinker is going to be turned off. And if I pass the right blinker on, then the left blinker is going to be off. So let's see if that works. I'm going to instantiate the car. Perfect. So I'm going to do my car blinker control, and then I'm going to pass left blinker equals on. So what happens here is I'm passing this on. So even though the right blinker value can be on, it'll be turned off. So let's see if that works. Okay, perfect. So now I have the left blinker is on and the right one is off. So what happens if I instead pass the right blinker? I'm gonna turn right. So now the left one was set off and the right one was turned on. So another quick thing that I want to mention is that if you can also pass or make these parameters be none. And what that means is that they might not even be passed, and they're going to be initialized with a non-value. So that's the way that you do, like, parameters that you want to be able to pass or not pass. It doesn't really matter, and you can make check if they're set or whatever. They can be passed. The last thing, and again, this is something for you to remind, is like if this is a required one, always put it at the beginning, and then the ones that are not required to the end. So that's it. I think we're ready to start building our Flask application, and play a little bit with this and have make up some fun more features to our car class. And if you have any questions, let me know.